Section 21.6, Evidence for Plate Tectonics. So it's interesting that we can kind of bring this chapter full circle, but one of the biggest pieces of evidence for this idea of plate tectonics, aside from the obvious physical things that we see like mountains and volcanoes, are earthquakes. If rocks are being pushed into one another, forced to compress and undergo immense pressure, then that rock can fold, much like the corner of a carpet folds. And if that stress gets too great, then the rock can break. And if you form a fracture that way, that type of fracture is known as a fault. If you have movement that occurs along a fault too quickly, it can generate an earthquake. What you have happen is you have two rocks that are moving beside each other, and for some reason one of them stops and catches. When it does, those plates still want to move. So it may stop and catch for a while, but at some point, the rest of the plate is still moving, and that piece will catch up. And if it catches up really quickly all at once, you have a giant shift in the plate, and that shift in the plate can generate an earthquake. So an earthquake is just a sudden release of stored energy within the earth due to some movement at a fault. When we talk about earthquakes, there are two important places that we need to talk about. The first is the point underneath the ground where the earthquake originates, and that's known as the focus. And then the point on the surface directly above the focus is known as the epicenter. When you see reports about earthquakes and things on TV, you hear reports of the epicenter of the earthquake. The epicenter is just the place on the surface that is directly above where the earthquake occurred. It does not mean it occurred on the land, it means it occurred below the land. But the epicenter just tells you where on the earth it occurred. Sometimes these movements between plates don't happen all at once. You could have smaller movements that occur before a really large movement, or you could have a really large movement and then smaller movements that occur after, or a combination. And so this is why you have what they call a major earthquake, but then sometimes you'll have foreshocks or aftershocks, littler earthquakes before or after due to smaller movements of that particular fault. So you get a small movement, you get a small little earthquake, another small movement, another small little earthquake, and then you get a big movement all at once, and that's where the big earthquake comes. And then after that, you have a few more little movements that generate some aftershocks. The foreshocks and the aftershocks, those earthquakes don't necessarily have to occur in the same place where the focus of the major earthquake is, but they will generally occur in a similar region, so nearby. What we refer to as the magnitude of an earthquake is just determined by the amount of energy that it releases. We use what's called the Richter scale to measure earthquakes. The Richter scale is a log scale, which just means for every whole number you go up, the energy released by the earthquake goes up by a factor of 10. So a 5.0 releases 10 times more energy than a 4.0. A 6.0 releases 100 times more energy than a 4.0. So every step up of one number, you get a tenfold increase in the amount of energy that's released. The way that earthquakes occur and where they occur can either aid or deter the way or how far that energy or those waves spread. So for example, if you have solid ground, earthquakes can travel a good distance. You can feel them very far away. I can't recall the year exactly. It was somewhere in the late 2000s, early 2010s. There was an earthquake in the northeastern part of America. And because most of the northeastern part of America is relatively solid below that region, the earthquake traveled for hundreds of miles. People felt it, I can't remember exactly where the earthquake occurred, but people felt it hundreds and hundreds of miles away. And that's because when you have a solid piece, if it shakes, you feel it through the entire solid. Now, if you have loose ground, the earthquakes may not travel as far. Those waves will kind of get lost in the loose ground. Since the loose ground can kind of move more than a solid can, a little bit of the friction from the ground and things like that will deter some of that energy, turn it into heat. In addition to the damage that can be caused by earthquakes, by the literal shaking of the ground, earthquakes that occur underwater can generate tsunamis. And tsunamis are just large waves of water. If you have a region underneath the ocean where, let's say, a plate shifts and a piece of it just jumps up 100 meters, then you've displaced a large amount of water above it. And that water is going to go somewhere. It's going to move. That energy, that wave that you generate, it's going to move. Think about throwing a giant rock in a pool. You create a big wave. It's kind of the same idea. You just move a giant rock in the pool and you create a huge wave. And that wave will travel until it hits something or until it dies out in the ocean.